Hey class. So topic for today is going to be completing the square. But before we get into completing the square, there's some math that you need to know. Okay, so we're not just going to jump right into it. Because completing the square is another way to solve polynomials of the form ax squared plus bx plus c equals 0. Okay, so we know how to do this a couple of ways. We know how to use factoring. If it's factorable, we can use the quadratic formula, or we can complete the square, which I think is probably the hardest way to learn. So it's probably always better just to use quadratic formula, but here's another method. But before we begin, let's go over some of these. So it's just like solving for x, okay? We're going to add 45 to this, add 45. We get x squared equals 45, okay? I'm actually going to leave a little space here, so we're going to put something in. Now, in previous videos, I taught you how to solve equations with radicals. This is the opposite of that. If we're squaring something, we take the square root to get rid of it. But there's a problem here. Whenever you take the square root, you need to put a plus or minus in front of the square root on the other side. And we get x equals plus or minus square root of 45. Now, if you could split this up, then you have to keep going. But if it was like 17, you'd just stop. But 45 we could break up. Because here we could say, okay, x equals square root 45 is 9 times 5. So we take out the 9, because the square root of 9 is 3. So we get, and plus or minus, we can't forget that. So x equals plus or minus square root of 9 is 3 square root of 5. Okay? So for this section, all our answers are going to have a plus or minus in it somewhere. So here we go again. First thing we want to do is get rid of the square, since there's nothing on the outside of this to move. So we have x minus 4 squared equals 25 originally. Take the square root of both sides and put a plus or minus. So we have x minus 4 equals plus or minus. This is perfect, so that's just 5. So we're going to get two normal answers out of this. Whenever you can take the square root of whatever's on the other side, you get two normal answers. Add 4, but you have to be careful here. Because whatever you're adding to this, the plus or minus goes with the 5, not the 4. So we could say x equals 4 plus or minus 5. So our two answers are 4 plus 5, which is 9, and 4 minus 5, which is negative 1. Here we have an extra step to do before we actually do that, but it's the same problem as this, almost. We get this thing by itself, so we minus 4. So we get 2x plus 1 squared equals, leave some space, negative 4. Because now we have to get rid of the squared, and the opposite of squaring something is the square root. And a plus or minus. So we have 2x plus 1, those cancel, equals plus or minus 2i. And then solve. So we minus 1. Remember, this number has to go in front of the plus or minus. So we get 2x equals negative 1 plus or minus 2i. And then divide both sides by 2, and we are done. Unless you can reduce it. But we can't, because 2 doesn't go into 1, we can't reduce it. So we have x equals -1 plus or minus 2i divided by 2. That's a fine answer. Another way of saying this, we could say x equals -1/2 plus or minus 2 divided by 2 is 1. So we could just say I there. So 2 forms of that answer there. I prefer this one. Sometimes in MATLAB when you're typing it, it prefers that. So it just depends. This one's not so bad. We're just going to take the square root of both sides. So we have 5x equals plus or minus 9, and then divided by 5. I'm done with that. So that was probably the easiest one. Because you can't even reduce 9 over 5. So that's our final answer, is x equals plus or minus 9 over 5. Okay, so now on to some actual completing the square problems. So here's our steps. First step, we get the equation into x squared plus or minus. Notice it's plus or minus here, but the equation only deals with one sign. So like here, it's minus, so we're going to use minus all the way through. Okay? So we have some x squared plus or minus bx plus, we don't care what c is. Okay, so that extra term on the other side of the equal sign. We just got to make sure that that term is over on the other side of the equal sign. Then, second step is to add b over 2 squared to both sides. Okay, so we have that blank term plus half the middle term squared. Okay, there's our middle term, it's going to stay the same. And then we factor it. Then we have some term over here. So let's look at a concrete example of that. So we have x squared minus 10x equals 11. It is in that form, so we're good there. Now our next step is to add half the middle term squared is 10 divided by 2 squared. Well, 10 divided by 2 is 5, squared is 25. So this is our term that we're adding to both sides of this. So we have x squared minus 10x plus 25, and notice we always add it no matter what. If this is minus, we add it. If it's plus, we add it. Equals 11 plus 25. And whatever you do to one side, you have to do to the other side. Okay? The reason we do that is because now this is factorable. Okay? And this will always factor. Well, let's think about it first. One number times itself will give us 25 that adds up to -10. Well, that's -5. So you can kind of cheat here. Half your middle term, which was -10, sorry, negative there, -5. It will always be positive in the end. Half your middle term is what goes here anyways. So we get equals 11 plus 25 is 36. Then we solve it with the method I was showing you earlier. Take the square root of both sides. Put a plus or minus. We get x minus 5 equals plus or minus square root of 36 is 6. So in the end, we could have factored this if we wanted to. If we wanted to move 11 over here, just factored it. That would have been the easiest way to do this problem. Add 5. And we get x equals 5 plus or minus 6. So we have two answers. X equals 5 plus 6, and x equals 5 minus 6. So x equals 11, and x equals -1. So there's another method to solving things of this form. Like I said, there's factoring, quadratic formula, which is probably the easiest, and then completing the square. So for number 2, we have 3x squared minus 6x equals 9. We want to get it in this form first. So right now, x squared is not by itself. So we want to divide everything by 3. Now luckily, we don't have any fractions here when we do this. Sometimes you do, and then it becomes a lot harder. So we have x squared minus 2x equals 3. Now it's in the right form for us to complete the square. Have the middle term, b over 2 squared, is negative 2 divided by 2 squared, which is negative 1 squared, or 1. So this is the number that we're going to be adding to both sides of this equation. That is step 2 of our process. So we have, I'll write it in 2 colors. We have x squared minus 2x. We're adding 1 based off completing the square equals 3 plus 1. Remember, once you do this, this side is always factorable. So what 2 things will multiply to equal 1 that add up to negative 2? Well, that's x minus 1 and x minus 1 equals 4. And then the process again. Take the square root of both sides, put a plus or minus. So we get x minus 1 equals plus or minus 2. Add 1 and get your 2 answers. So again, this one was factorable. We probably could have seen that here. When it comes down to it on a multiple choice test, if you don't have to show your work, just factor it, because it's way easier. So we have x equals 1 plus or minus 2. And then our 2 answers, 1 plus 2 is 3. And 1 minus 2 is negative 1. All right, so 2 more examples. So first step, we want to get y squared and y by itself. So we're going to minus 41. So we get y squared plus 8y. We're going to leave a blank spot here, equals negative 41. And now we'll complete the square. So like I said, to complete the square, we're going to add half the middle term squared to both sides. Well, half the middle term is 4 is 16. Okay, so we add 16 to both sides, which makes this factorable. Okay, so we have y squared plus 8y plus 16. What 2 numbers multiplied equals 16 that add up to 8? Well, that's going to be y plus 4 and y plus 4. So y plus 4 squared. Notice we're skipping some steps there. Equals negative 41 plus 16 is negative 25. Maybe leave some space here. Okay, so now take the square root of both sides and a plus or minus. So we have y plus 4 equals plus or minus, what's the square root of negative 25? That's 5i, right? We just did imaginary numbers. So we can do that. And then we minus 4. And we're actually done with the problem after we do that. So we get y equals negative 4. Remember, whatever you move over goes in front. plus or minus 5i. Cannot add them because they're not like terms. So we get our answer. All right. So now one more. So we have 3x squared equals negative 5 plus 4x. Well, right now it's not in the right form. We need x squared and x on the left. So we're going to minus 4x. Right? So we have 3x squared minus 4x equals negative 5. So this one's going to be a little harder because now we have a number in front. So we're not allowed to have that. We have to divide by 3. Usually you're going to have these types of problems where you don't get any fractions, but here we do. So now we have x squared minus 4 over 3 x equals, well, actually leave some space because we're going to complete the square, equals negative 5 over 3. Here's where it gets hard. Half the middle term squared is negative 4 over 3 divided by 2 squared. Whenever you divide by a single number, you're really just multiplying it with the bottom. So that's 2 times 3 is going to be 4 over 6. Which can reduce to negative 2/3. Then we square it to see what we're adding to both sides of this equation. So a little bit of fraction work there. So we get positive 4 over 9 that we're adding to both sides of this equation. Positive 4 over 9. So we're going to need a common denominator here. So we can go ahead and deal with that right now. These both need to be 9s, so we're going to times this by 3. So we can combine those. So the new equation becomes, we can factor this. God knows who to do it, but there's a trick. It's going to factor into that half the middle term. So this is what we're going to use that it's going to factor into. We got x minus 2/3 squared equals, well, this is negative 15 plus 4. So that's negative 15 plus 4 is negative 11 over 9. Then we take the square root of both sides and finish the problem. So we take the square root, plus or minus, we get x minus 2/3 equals plus or minus square root of negative 11 over 9. We'll add 2/3 to this side. We get x equals 2/3 goes in front. We could take the negative out. That's an I, right? Because we have a negative on the inside, so we can take it out and it becomes I. Because it's not simplified unless you take that out. 11 over 9. And the final way that they're going to want this is 2/3 plus or minus the square root of 9 can come out. So we could say I square root of 11 over 3. And you could put that into a single fraction if you want, but we're going to stop there. We're out of room anyways. So that's a proper answer. If you want to put it into a single fraction over a single 3, we'd have 2 plus or minus I root 11 over 3. That's it for today.